Okay, here is our board work for today. It's kind of a continuation of what we were doing the other day. I'm gonna try and make this video quick just because my time's kind of limited, but I'm gonna give you guys access to the PDF that I have right here that I'm scrolling through. So, board work, phase plots, day one. Create a first quadrant phase plot for this system right here. So go ahead, pause, and give it your best shot. All right, I'm going to scroll down to the answer. Okay, so this thing has two critical points, 0, 0, and 75, 50. I find them by factoring. So get this line right here. We'll set it equal to 0, factor. 0, 0 is this and is x and y 0. And then once I make x 0, I can't like pair it with this thing because that is a different x. That would be a different x value. So then I just pair these things in parentheses, which would be 75, 50. Next thing I do is I find the Jacobian matrix right here. The thing you want to be most careful of, I think, is just like double checking your partials as you go through. Make sure that this one is correct, that you're actually doing the partial y of this one. You should have a 2y here. I feel like this and this are the two spots where you're most likely to kind of mess it up, or maybe even this one. Anyway, just be really careful with your partials. 0, 0, I get this really nice matrix. Why is it really nice? Because it's triangular, so I know the eigenvalues. And that's going to happen a lot. I think you'll see that. The eigenvalues are the entries along the diagonal, 200 and negative 150. The 200 is great because I get zeros in this column, which means I could take 1, 0. Same thing here, I get zeros in this column, so I could take 0, 1. Its phase plot is this thing. It's a little saddle. This next one, 75, 50. My characteristic equation, the trace is 0, so there's no lambda term. And then when I do my back deet, I get this plus, what is that, 30,000. And when I move it over, I square root, and I get plus or minus an imaginary number. The reason why that's really nice is because it's just concentric circles. When you go back to these imaginary or complex eigenvalues from before, when we were first learning this back in maybe February, um, you had this like long process using Euler's formula where you had to work out an equation, right? But here we're not getting an equation at all. We are only like I didn't get an equation for this one. We're only getting a phase plot. So once I get here, I know I've got concentric circles and I can stop that work, that eigenvalue work there, right? Um, so I draw my concentric circles, and then in this case, I know that these are going to slide to the right because it's got to match this, right? I know that these are going counterclockwise because it's got to match this right flow here and this down flow here. So, yeah, that one, only two critical points. And once you like figure out these shortcuts, I think they go pretty quick. So let's move on to the next question. Same thing, just a little bit more complicated. We've got x prime, x squared minus 2x minus xy, y prime, y squared minus 4y plus xy. Let's go ahead, hit pause, and make your phase plot. All right, maybe I'll go down to the solution so you can see it. There it is right there. Got those critical points right there, 2, 0, 0, 4, and I think this is 3, 1. So let me go through the solution. Um, Factor to get the critical values. There are 4 of them, or critical points. 0, 0 should be obvious. 0, 4, what's that come from? That comes from making this, the top equation 0 by making x 0. Once I do that, this value is 0. So you should see y minus 4 has to be 0, which would make y equal to 4. This one's the same thing, except for it's kind of inverted. Other equation, other in x instead of y, to get 2, 0. And then 3, 1, where's that come from? I take these parentheses and set them equal to 0, and that gives me this, which however you want to solve it, do it. This one, I think you could probably use elimination pretty quickly, but we can also REF it and get 3, 1, which is that. All right, so I've got 4 critical points. Bam, bam, bam. Find my Jacobian, right? Once again, be really careful with your partials. And then it's a little bit more work to plug these guys in. 0, 0 is not bad. Zeroing out all the variables in this thing just gives me a 2 and a negative 4. The zeros everywhere else. It's triangular, and it's nice like the one from the last example. Zeros in the columns means I can take a 1 in that column and 0 everything else out. Same thing here. There's a 1 that pairs with these guys right there. Gives me a sync node that is straight up and down and straight side to side. 0, 4. I was really careful when I was plugging these values in. For me, I know I'm going to mess it up if I try to do it in my head. So I, what is it? X is 0, so that guy's 0. And then this is 4, so it's like -2 minus 4. And that's what I wrote in here, right? Clearly 0, clearly 4, and then an 8 minus 4. Then I simplified to get this matrix. Once again, awesome, it's triangular. So I get my eigenvalues. This one is one where I can zero the column, right? With that 1. And then this guy, I want to get in zeros across one row. So what I can do is flip this this row and negate one of the terms. And I did that and divided by 2. So 10 negative 4 would work well. Either way, that gives me a saddle over 10 down 4 over 5 down 2. And then up and down is this guy right here. Come down here. This one's really similar. If you can check the work on your own. I'm not going to walk through all those spots because it's really, really similar to the one up there. Here, this one right here, 3, 1. Once again, I'm going to be really careful plugging the X and Y value into this thing. Make sure I don't mess it up. Hopefully I didn't. I don't think I did. I do my characteristic equation with my trace and my det, as you guys all know how to do. And then this thing, not factorable. You can do it in one of two ways after it's not factorable. Well, it's not factorable in real numbers. After it's not factorable, you can you could use quadratic formula. Some people like to do that. Or we could complete the square. I like completing the square, and maybe that's because I'm a math teacher, but that's the way I did it here. The 6, I just kind of ignored it at first. I looked at the 4. I completed the square on that, so I added what I would need to factor it into something like this, which is a 4. And then I said to myself, well, what else do I need to get my 6? I need to do +2 because that's how I get to 6 from 4. So I move the 2 over, and then I factor. It's a square. That's the whole reason we completed the square. Square root, that gives me the plus or minus root 2i, and then I move the 2 over. So once again, just like the last one, when we do these, all we need is the visualization, right? Once I get to this spot, I know I'm going to have a spiral source. I don't need to go through that long process of sines and cosines and e to the and Euler's formula, an imaginary C1, C2, right? We don't have to do any of that right now. We know it's a spiral source. Why is it a spiral? Because of the imaginary part. Why is it a source? Because it's got a +2. If it was a -2, there would be a spiral sink. So my next step is to put all 4 of those together. Here's my sink at 0, 0. Here's my saddle at 0, 4. Here's my my saddle at 2, 0. And really what I would just do is put a dot here. And then I would do a spiral. It could be like a really light, unwound spiral, I guess we could call it. And this one, it's kind of hard to figure out the direction of this one. I use this example every year, but I've got to have it match this flow, right? So I'm going to make that guy go out. I think you could actually have it flipped the other way. I could have a spiral that went like this and into there, and then like this and into there. And I guess you could try to figure that out, but either way, I have a spiral that goes out and hooks to here, and then I'm going to take this guy and hook it to there. I always like to connect pieces between critical points if I can. So knowing that this is a spiral source and that it's going to spin out and somewhere it's going to hit this, I'm just going to draw one and say, all right, that's the one that's going to go over and hit that. And draw one on the other side, and that's the one that's going to go over and hit this. When I connect everything, I get this spiral whoop up out like that. And then I'm gonna, I made that one piece dark because it kind of separates two different areas. One where X and Y's both go out to infinities, and then the other here where X's and Y's both go down to 0, 0. So with this phase plot, I've kind of got a two spaces. One space is where everything flies out to infinity, and the other space is where everything goes into 0, 0. So hopefully you're good, and that helped you practice that a little bit, and we will keep doing this so that you can get good at it. So I hope you're all doing well, and I will see you soon. Bye.